Jasper, would you like to come on stage to say hello to us? Welcome.
Hey, how are you doing? Can you hear me?
Yes, I can hear you perfectly. How are you?
I'm doing really well, thanks.
Good. It's so good to have you here. When I saw your talk on the schedule, I was like, yay, he's joining us.
Chuck asked me to come on spontaneously, so I'm talking about something a bit unconventional for me. I'm a bit nervous about that.
Oh, no, come on. I know you're going to do great. Come on. So I'm just going to let you do your thing. Okay.
Mhm.
So welcome to Pajamas. And yeah, looking forward.
Yeah, thanks. Well, I'm Jesper. I do stuff online and I do machine learning and all that stuff. I should probably share my screen. I hope all this works. There we go. All right. So I have recently been really obsessed with Advent of Code, and I'll get into that in a bit, what it is and why I'm so obsessed with it. But I really love it, and especially since it fits into a couple of theories I have about reinforcement and machine learning. And if you don't know what those are, that's fine as well, because I'll talk about those as well. I have 20 minutes to fill, and this is all very... It fits with a cozy pajamas feel. Like, it's very improvised. So yeah, let's see. Advent of Code is this idea that you have an advent calendar for your brain. So essentially what's happening is that every year since 2015, Eric Watzel, a single person, if you believe it or not, sets up this amazing thing where each morning at midnight in Eastern Standard Time, a new puzzle unlocks. And you can solve those puzzles by hand or with code. People learn new coding languages or improve their Python. I use it to improve my Python, for example. And there's something different about it. And I want to talk about that. I've seen Eric's talk online as well, and I think it's really impressive what he does in this project. First of all, like from a hardware standpoint, but also from the puzzle standpoint, because I think a lot of you have tried like things like LeetCode and HackerRank, where you improve your coding capabilities. Like before my interview with Amazon, they told me to go to HackerRank and basically do programming challenges to improve my coding capabilities. And while they're nice, I think they're missing something. And it's nothing they can actually improve. They have a different target. So Advent of Code, you can go there, adventofcode.com. It's free. And each day you have this new thing. You can see it right here. I'm actually going to hide that. It's quite nice. So this is from 2019 and it builds up. So in 2020, you see a different image, and it's a different story as well each day. And each year it's a different story, and each day you try to solve part of that story, which is cool. And also sometimes, so I'm not gonna lie, I can't solve some of the problems. They are very variable in their complexity, and some of them are incredibly hard. As you saw maybe on the last one, I haven't finished one yet, mostly, well, because I just finished my PhD and I didn't have time to commit to this for a full month, because some of them take hours to solve, at least for me, because I don't have the right expertise in some of the coding things that others have. But yeah, I hope this year I'll actually finish it. But yeah, you get this story, and there's always a first part and a second part. And the first part usually is a bit of a simpler version of the second part, which is really nice, because in the first part you can also already build up a little bit how the second part is going to go, which, yeah, that makes it very interesting in a way to see how to generalize your code in different environments. So when you have a very specific problem of doing this one thing, you can think about, all right, how would I solve this for like a more general case? So one example, right, that I solved today was assigning it's very random, but if you actually do it, it makes more sense. But assigning plane seats, and you want to find your one seat, and well, in the beginning, you're supposed to like calculate from a different code where your seat actually is, and then in the second part, you're supposed to calculate where it actually is in the seat. So from your ID, locate your seat. And it makes more sense in the aspect of this data, because what really happens here is you have to think through your puzzle input, how to solve it in different ways, and it's amazing. I love this. Here you can see some stats on this, which is the other part that is very impressive to me. Down here, oh no, no, let me try with a pointer. Well, you can see the numbers. So the finishing rate is clearly a long tail. Not everyone finishes in the end, but 100,000 people get both of the experiments right on the first day. And for a single person that is running these experiments with different inputs, that is already an engineering feat. So this runs on AWS, but of course, Eric doesn't tell us a lot because security through obscurity, a lot of the behind the scenes stuff is hidden. This year, it actually happened that the servers crashed. Eric managed to have these huge warm-ups and all this balancing and like a lot of stuff behind it. He's been doing it for 5 years, but the server still crashed. And usually that doesn't happen. Like when you see like 100,000 people that from which 10,000 all open it at midnight because there is a run for the leaderboard, and the servers don't have any buildup, right? Usually when you have like balances on web servers, this balancing is happening over, well, you have a ramp up like on Black Friday. Usually people open up the websites a little bit before and there's a ramp up. Usually you can use load balancers and they get accustomed to it, but not with Advent of Code. Advent of Code literally starts on one day. It's like for the physicists among us, it's a Dirac spike. It's just getting a lot of traffic at once. And it's happening to a lesser degree, but it's still happening at midnight every day, which is just from a hardware perspective, even if you're in the cloud, even if you're scaling over different clusters and all that stuff, like even if you run Kubernetes, it's a problem. And like I think it's fascinating. Definitely, like after Pajamas, look up his talk on how he does a lot of it. But of course, like that's just my admiration for this problem and for this project. Why do I love it so much? It's guided exploration. And this is also the thing that I kind of want to talk about today. These puzzles always come with an input file, which is just a text file. So you already have to start by dealing with irregular text files. They have different inputs for every day. And sometimes they're numbers in a text file. So when you read them in Python, you do your open with open and get numbers in text. So you have to convert a lot of numbers that are in a list, which made me realize how powerful the map function is, for example, and things like that. So you start building up in these mini projects where you're trying to solve a thing. And the really fascinating thing about Advent of Code is that there is no prescribed way. And that's my main difference to like HackerRank or LeetCode, where if you open those, it's usually that you open a lesson on KD trees. You open a lesson on efficient looping. And the problem there is you already know how to solve it. There's no flexibility in approach. You're already told, do this to solve this, but within these parameters, solve this. And today, the solution, I don't want to spoiler it for you, but there were two very different approaches. There's a subreddit, and I love the subreddit with it because everyone is super helpful, and you can see like people are doing this even like in Excel and everything, but you can see how other people solve this, and therefore also see different approaches that you can learn from, which I love this about this, because you have spent like half an hour, maybe an hour on thinking this problem through, and sometimes there are solutions that you didn't even think of, and you're like, wow, this is really eye-opening. And I mean, on a wider context, this already tells the story why we do pair programming, why we have other people review our code to see, right here, if instead of this range you use enumerate, then you get your index for free without having an additional computational cost, things like that, right? So seeing different approaches to this is amazing, and also not being told how to solve it. So today there were hints in the solution to a binary space partition, which is a way of dividing up a space in a yes-no fashion after some rules. And usually you do that by building up a binary space partition tree. And usually building these trees is a little bit expensive because you have to preload all the calculation. And but then they're extremely fast, so you can solve it in that way. I solved it in a very different way, which ended up being extremely fast, and I was really proud of that solution. And sharing that then on the subreddit was really cool, because someone actually answered to it and said, "Oh wow, that is amazing. I'm gonna try that in my language." So they read my Python code and implemented in their Kotlin, and like also. So in his talk, Eric talks about how he spends a lot of time trying to make the text ambiguous. So you are not forced into a certain direction, unless he wants to put a red herring in. That happens too. But usually these are so different people from different strokes can participate in this. Last year, we basically built a little compiler that was a robot that could like walk up, left, right, and then do something. And with each puzzle, you build up this robot piece by piece. What I did was I learned about classes the first time, because I mean, my background is physics, so we do a lot of functional programming because it comes natural. But yeah, I built a robot class. I learned a lot in that process about different processing approaches. I built up a queue of input commands. And the interesting part is, I mean, I don't have a lot of experience in web development, like from an actual development. Like my websites are either static or run on WordPress, so I don't really have to do anything with them. And it was really interesting because the queue that I built was hand built, essentially, just like a list that was built up, and then if a new command could be executed, that list would be called. People that have experience with web development directly went to asynchronous functions. I should definitely look them up. That's also kind of where I stopped, because I didn't have more time to solve these problems. But yeah, like you can see so many different ways to solve these, which is amazing, because this also gives you the opportunity to grow. Because I now know that I should definitely have a look at asynchronous functions, but I also know vaguely how they're used. because in a web sense, it's like, it's sometimes a bit hard to understand them, right? Asynchronous functions, they kind of have to wait on inputs because sometimes servers are laggy. So like there's always a delay. So you want to wait, but it's kind of abstract because I don't live in the web. I'm a physics person. I usually have my data right there on my hard drive, or sometimes I have to wait for my data to be loaded, but it's loaded and then I do something with it. It's not that anything has to really work asynchronous, mostly. But yeah, it opens your eyes to these different solutions as well. I think that was actually some of the key info already. Like one of the things that Eric is extremely proud of, and I think righteously so, is this approach of doing things ambiguous to give you the space to develop a creative solution. And this creativity is something I love. But you still have this guide of, there's a number you have to get out of it, and the number has to be right. So you have confirmation as well. So there's a reward in the end. And for some, it may be natural where I'm going next. What does this have to do with reinforcement learning? Well, let's talk about what reinforcement learning is first. Reinforcement learning has a lot to do with games. Essentially, it's showing a computer to play a game, or more generally, it is showing a computer how to do something in an environment you define. And for most of you, it may now be clear how I'm making this connection, because defining this environment is the most important step in your reinforcement learning approach. So when you set up your Game Boy or Atari games, they're quite popular in reinforcement, or you play Go, this is directly taken from the DeepMind webpage, where they beat one of the champions in Go with a computer, which everyone thought would be impossible. And it would be impossible without these reinforcement learning algorithms that essentially play against themselves and learn just based on the rules of the system, which is why reinforcement learning is making such strides in games. Reinforcement learning has been used to play computer games and beat humans in like actual 3D shooter situations and all that stuff. But it is going into other fields as well. So reinforcement learning is being used in a lot of logistics as well, where you can define the parameters of your environment and think about it. Think about it in a way that you just set an agent in there, and the agent can explore curiously, and you can set the constraints. Now, why do I think this is so similar to Advent of Code? Well, Advent of Code gives you an environment, like a reality you accept, and you explore that reality with or without, depending how much experience you have, with the experience you already gained. So when you're coming from a web background, you are probably finding a solution that is much closer to your space with asynchronous functions. When you work a lot with arrays and lists, you're building up a list that is just appended and a queue system essentially. So really, reinforcement agents also learn with experience. And there's something interesting, because AlphaGo, which was the agent that won the game, was trained on so initially it was trained on games that people played online. The next iteration was played without any. So it was just AlphaGo playing against AlphaGo and learning from that. And quickly it became better than any other agent that was learned on human behavior, which is slightly frightening, but also really fascinating. However, we don't all have Google resources, right? We don't have, like in some cases, millions of dollars to spend on on cloud instances. And in this case, I've seen some really cool things where people were playing Mario Kart and like training a reinforcement learning algorithm on Mario Kart, and it would get stuck because if it runs into a wall, it's really hard for the agent to get unstuck to learn that. But if you, in some cases, make interventions, so basically nudge it in the right direction, it learns much faster. So you're shortcutting some of the exploration and essentially doing pruning. So you're making some, well, you're optimizing some of the solutions because you're saying, hey, not that way. We want to stay on the street. It's fine if we don't explore over there in the grass or in the water or in the sand, because that's just not a solution we're looking for. So oftentimes learning without any guidance is much more expensive. It can lead to extremely beneficial outcomes, but it's like, when I say expensive, it's computational, but computational in this case is on GPUs in the cloud, so it's actually expensive. And using guided exploration with these constraints can significantly improve your reinforcement learning. What does it have to do with machine learning? Well, in machine learning, what we're trying to do is to get a computer to find rules. And oftentimes, always it's based on data, and sometimes it's based on labels or on unsupervised learning. But the idea is that the computer figures it out for you. So some strategies that are very similar to this guided exploration are feature engineering. When we already know that, for example, in housing data sets, very classical example, the raw features are square feet and price. But if we look at price per square feet, we have a feature that is extremely beneficial to figure out where something is placed, because you pay much more per square feet when you're close to the water or when you're high up, things like that. Hard negative mining. When we know something is going wrong and we don't have more data, we can get the things that went wrong and refeed them to the algorithm and do fine-tuning on the things that got wrong. And like variance monitoring is something we can do, like in Bayesian optimization, essentially go into the places of uncertainty. So when our machine learning algorithm is doing relatively well everywhere, but the variance of the outcome is higher in certain areas, we want to go into those areas to guide them to these areas to improve and gain more certainties, so we reduce the variance in those areas. And of course, dataset augmentation. So I just heard you work with Sentinel data. I do too. And we're just contracting with a company that is doing, which is collecting a data set for us. We need labels, so they go in the field and they say, this is a plantation, this is man-made, and well, we can tell them where to go, because sometimes we have a lot of data just from interpreting satellite images, which is easy. Like looking at, well, relatively easy, but we can look at these satellite images and get easy solutions fast. Like we can look at water. The water is very easy to identify in most satellite images. But if we want cocoa plantations, it's really hard to distinguish a cocoa plantation from an orchard. So we actually need to calculate data there. So we can guide our solution by actually getting more data in areas where we need more data. So having this kind of guidance within an open exploration field is really important as well. And this is kind of an interesting thing that I just found during Advent of Code, that to me seemed very similar between Advent of Code, machine learning, reinforcement learning, where you realize that opening up the parameters can be very, very beneficial. And sometimes guiding into the right direction is speeding up a solution very quickly. And that's all I have for today. Meet me online. I'm on LinkedIn. I have my website. Write me an email if you like. And yeah, thanks for listening.
Yeah, thank you. Thank you, Jasper. That's a really good talk. And oh, you're gone. I was about to have some chit chat with them. Oh, that's okay. um, oh, they're back. Hey,
Sorry.
Jasper.
That was the wrong button. It was not end share.
Oh,
That was leave studio.
yes, there's a actually for people who don't know, there's a big red button at our backstage there, and lots of speaker when they are testing, they just disappeared. That's okay. I don't see any questions on the chat, but I do have a question. I think it will be very useful for the viewer. So what do you think is the most dangerous pitfall for beginners who are starting to do some machine learning or training some models? Like, what's the easiest mistake or wrong concept that beginners would have?
Oh my.
It's a very difficult question.
That is actually a difficult question. I feel like you have a lot of experience in machine learning too. What is your opinion on this? Let me think.
Okay, so I would think that a lot of people, they don't understand that actually sometimes training a very sophisticated model, they need a lot of data and a lot of time, lots of resources. They just overlook it and thought it's an easy job. So they would, and then just go downhill from there. I was one of them. So
Oh yeah. Now that you say it, so in the very beginning, I think it's very easy to find like easy data sets, like the Boston housing data set and MNIST. They're basically solved, right? There is no challenge in there. And like going from there to actually applying work, like data is always messy. And sometimes it's more messy, sometimes it's less messy, but there is no way around like data cleaning and also like making your data cleaning pipeline robust. That's definitely something. And yeah, you're right, also going too complex too quickly, because to build complex models, you need a really good data validation, model validation. So you have to do cross validation and you have to do it in the right way. And that's, like, in my opinion, that's the most important thing to learn in machine learning anyways. Like, the models don't matter that much. Like, they do, but they don't. But model validation, like, if you don't do cross validation and you don't do it in the right way, you're probably not getting a good solution. And you have to kind of learn your ropes on that from the ground up. Like, going deep learning right away is probably a bad idea.
Right. I think that's so true. That's exactly what I think as well. And so my last question, if people want to learn more from you, where can they find you?
I'm
have
all
a
over the
course, right?
internet. Oh,
You have a
yes.
course, right?
So if you already know Python, I have a data science course where I teach a lot of like this validation, and like how to build up your data science knowledge, from data cleaning to exploratory data analysis to machine learning. Thanks for the pitch. It's on my website. I can give you a link if you write me an email. But it's also if you find me on Twitter, it's just my name, Jesper Dramsch. It's right in the bio, so in the first pinned tweet. So it's everywhere.
Or you can share on Discord. Just let
I
people
can do
know.
that, yeah.
I think some of them may be interested, and there's also a data science channel in the discussion. So it's quite quiet right now. I think people get a bit scared of data science, but if just you started, then maybe there will be some discussion there, hopefully.
I can try and fan on the fire for data science a little bit, yeah.
Definitely, team data science.
Yeah.
Okay, so thank you so much, Jesper. It's good to see you again, and hopefully see you more in the future.
Thanks for inviting me, and yeah, have a good rest of the conference. Bye.
Yeah, bye.